So I think we're ready. You're all so very welcome to the meetup number 12. It's incredible how we're already on the number 12, and the number of people on the meetup page are over 2,000, and I'm extremely happy about that. So it's very nice to see such a huge turnout today. For those of you who don't know me, I am Sarah. I work in HubSpot. I'm a tech lead here, and I'm here for just over 3 years. So I also hope that you liked the food and the drinks today. We will have additional batch of ice cream set up in the kitchen just after this first talk. So whoever didn't get to get any ice cream, be sure to check it just after this talk. These are today's speakers. So we have two interesting talks. First one is Trevor talking about React testing techniques. Trevor works in Cambridge. So for those of you who don't know, Cambridge is in Boston, in Massachusetts, in the States, and not the Cambridge in the UK. And then we have Roxana from Facebook talking about relaying hooks. So just a quick note, HubSpot as always is hiring. We're hiring pretty much for all roles and all levels. So if you're interested, we always get a lot of questions, who can you talk to? So this is our jobs page. Be sure to check that out, and be sure to talk to any of our recruiters who wear the t-shirt so you won't be able to miss them. So this is a quick look at the agenda. So we had a little bit of networking of food, a quick introduction to the event, and then we will have our talk number 1 now, so React testing techniques. After that, we will have a quick Q&A for that talk, and we will have some 15 to 20-minute break, depending on how long we need. So make sure to take some more drinks, some more food or ice creams, and make sure to come back to this room so that the kitchen doesn't get too crowded and you can all continue to breathe. After that, we're going to have the second talk, relaying hooks. So with that, I'll welcome our first talk, which is Trevor.
Hello, it's great to be here. This is my first time visiting Dublin. I'll be talking about testing React components. I'm told that all great talks start with an agenda slide, so here's mine. I'll start by talking about tests in the abstract and your choices for testing React components. Then I'll talk specifically about shallow testing with Enzyme and why I find that to be a particularly interesting way of testing things. And then I'll talk about render performance and a tool called Puppeteer and how you can use that to find out how fast your components are. And you'll forgive me if this talk is a little scattered. I know you guys just had a testing talk back in January, so I figured you wouldn't want a testing 101 talk. So who am I? Well, I've been at HubSpot for 7 years, back in Boston, Massachusetts. And I'm the author of a book. This just came out 2 months ago, Test-Driven React from Prague Prog. Very proud of it. And my day-to-day at HubSpot is building React components. What kind of components? Well, modals, panels, popovers, tooltips, dropdowns, pretty much anything you interact with in a HubSpot app. There's a good chance that I wrote the lion's share of the core logic there. And you can check out those components at canvas.hubspot.com. We call it the Canvas component system at HubSpot. But I will warn you, this website hasn't been updated for about a year now, so this doesn't represent the latest and greatest stuff we've been doing. So part 1. Testing. So if you want to learn about unit tests versus integration tests, you do a Google image search and you're guaranteed to come up with something like this. For some reason, it's always unit tests at the base, then integration tests on top of that. Sometimes there will be another layer that's like your Selenium test where you're actually running the app. This is a good representation. I like this even better because there are 2 pyramids. And as awesome as that is, you can't beat this KICKBOXER that I found. This is a page from a book on integration testing, so I'm assuming that the guy on the left is integration tests. So what makes these 2 things different? Unit tests is, of course, as the name says, isolated, meaning in principle, it's only testing the module that you're pointing it at. Then it's abstracted, and by that I mean it's not really involving your core business logic or things from a human perspective. It's much more from a machine perspective, is this code working? And it also tends to be much faster than an integration test because it's hitting fewer code, fewer modules. Integration test, by contrast, it means you're hitting multiple modules. You're asking how these things fit together. And this often means asking more concrete questions of, okay, what happens if a user does this? And as a result, because you're hitting more code, these tend to run more slowly. So which should we prefer, unit tests or integration tests? Well, of course, these are kind of blurry categories, really. There isn't a clear line between the two. You're going to use a mix. And if you step back and ask, what's the purpose of testing? Number one with a bullet has got to be reliability, right? Like, that's the business case for testing. But there are other reasons that are a little more interesting. One is this question of feedback. Like, how do you know that you're making progress as you work? Setting up a unit test before you implement a feature and seeing it turn from red to green is a great way to tell yourself psychologically that you're moving towards something. And I talk a lot more about this in my book, about the advantages of TDD. And finally, you can use tests for exploration, meaning to answer questions about your code that might be difficult to answer otherwise. So let's look at the options for testing React code. Enzyme used to be the de facto standard. It was everywhere. And it's still very popular today, but it's got some competition, as you'll see. It's a very versatile framework. You can do pretty much anything with Enzyme if you know how. But because of its versatility, it can be very difficult to figure out how exactly to use it. And it hasn't really caught up with the React ecosystem's new features have come out. So for instance, if you try to shallow test something with hooks, it probably won't work. React Testing Library, on the other hand, is the hip newcomer. It came out just a year and a half ago, and it's skyrocketed in popularity since then. It's very focused on the idea of you just want to find out what do you see in the DOM when you run your components. And as a result of that, it's a lot easier to learn than Enzyme. There's really only one way to use it, as opposed to the numerous APIs offered by Enzyme. And it just feels a lot more straightforward. So I'm not here to praise one of these libraries too much. I think they're both great in their own way, and they can complement each other. The React Testing Library philosophy in their README is the more your tests resemble the way your software is used, the more confidence they can give you. And if you think back to those definitions of unit testing and integration testing, this should sound familiar. What they're really talking about is integration testing, or rather something closer to the integration end of that unit integration spectrum, which is why I like shallow testing in Enzyme so much, because with Enzyme, what you see is what you test, meaning that you can look at a module and know that the shallow tests against that module are only testing the behavior of that module. They don't depend on anything else. It's a true unit test. So let's look at some specific examples of where that can come in handy. So I want to start by talking about why, to show an example of how odd Enzyme is in its API. Let's say we have a component called a blue paragraph. It always has class name blue. And we try this test. We try creating a shallow wrapper around it, setting class name red with that wrapper, and then we ask, what is the class name of this wrapper? And you expect it to be red, but no, it's blue, because what Enzyme is telling you is the class name, what the class name is on the component within the wrapper. And this is a really odd API if you think about it, because conceptually, this shallow wrapper is representing two things here. It's representing both the wrapper around the component that's injecting props into it, and also the component node itself. And really, it also represents a third thing, which is the internals of the component, because you can ask questions about state with that wrapper. So I think this lack of conceptual clarity is a big reason why Enzyme can be overwhelming to a lot of developers, and why they've been pretty quick to exit for an alternative. But on the other hand, let's say that we're looking at a higher order component. Now this is interesting. This is a component that doesn't really put anything in the DOM in and of itself. So let's try wrapping a dummy component here. Simplest possible component, just renders null. And by focusable, I mean that this is a higher order component that injects a prop called focused into the component so that it knows whether it has the keyboard focus or not. All right, so do we expect that initially that dummy component within the wrapper is going to have prop focused equals false, and this test passes. And then we can try simulating focus and see that that prop changed to true. And focus and blur, yep, it goes back to false just as we'd expect. Now, of course, you could express these tests with React testing library by creating a dummy component that renders the focus prop into the DOM, but I kind of like the way that shallow testing it is nice and direct. You get to directly ask this question of, well, what is the prop that this HOC injects? And a lot of what we're testing when it comes to React components really is this sort of plumbing of which props are routed where. And I think shallow testing excels at that, especially when the internals of how a component works with props are kind of tricky to figure out in terms of the DOM result. So let's say we have a drop-down component. This is something that will render a menu inside of popover. So we start by putting a dummy menu into this drop-down component. And if this convention of a component prop looks odd to you, I'll talk a little bit about that later. And we start by asserting that that when this dropdown is closed, there's not going to be anything in the popover. The popover content is undefined. And this test confirms that. And then this test says, okay, once we set the open prop to true, now that component prop is passed through as the popover content. So this is interesting because it means we don't have to worry about the popover implementation details. Like if you're using tether or something to render the DOM content, you don't have to worry about that at all. No matter what's inside of the popover, it's simply not being executed here. It's purely a shallow test of the drop-down component, which means that you're guaranteed that these tests won't break if you end up changing the internal implementation of your popovers. Shallow testing can also be useful for side effects, such as performance impacts. So here, this is based on a real example. We have a tabs component in Canvas where this component measures its own width when it's mounted in the DOM, which is, of course, a very expensive operation. So we want to be careful about exactly when that method is called. So let's stub out that method. So we'll tell Enzyme disable lifecycle methods, meaning we don't want you to call any lifecycle methods. We'll do them on our own so that we can stub things out first. And this is where we actually stub out that measure width method inside of the tabs. And we check that, okay, if we call component.didMount on a component instance, then it performs this measurement. And if there's a resize event, then after 50 milliseconds, because let's say it's debounced, then that measure will be called there as well. So this, again, is a nice direct test of exactly what we want. That would be very difficult to replicate with a DOM-based testing approach. Now, of course, some of you might be saying, why would you have so much complexity inside of a tabs component? Shouldn't we extract that out to something reusable? Well, sure, let's try that with a reusable higher-order component called measure. So measure has the same behavior that we just saw, where on mount, it's going to measure the dimensions of the component and inject those in as props. So we wrap a dummy component with it, shallow render that measured dummy component, and then we simulate the measurement by setting state in the component. I know this, you may have been told that mucking with the internals is a testing no-no. I sort of agree with that, but I would also say there isn't really any way around that in this case, because the alternative would be to simulate that DOM measurement, which is also based on the internals of the component. So we want to know that that measurement state is passed down as a prop into the dummy component, and indeed it is. But what's more interesting here is we can test that after an identical measurement is performed, that same object, that is a reference equal object, not merely an identical object, is passed in, so that we don't have a performance hole here where we have unnecessary updates every time measurement is performed, even if those measurements are the same. So this, again, is something I think shallow testing is very useful for. And that's why I love shallow testing, although, of course, all the examples you just saw used higher order components, which are sort of going out in style in favor of hooks. And if you are using hooks, then shallow testing is useless to you, and you should instead look to React Hooks Testing Library, which is the official companion of React Testing Library. Now, that segues us into performance. Let's talk about What happens when someone approaches you and says, this component of yours, it feels slow? Well, you might start by asking them, are you looking at it in production? Because if they're looking at it in development mode, there are a lot of things that can skew performance characteristics there, especially prop type validation. Prop type validation runs every time a component receives props, even if they're the same props, so it's a pure component, it wouldn't update. Really doesn't matter in production, but would slow down dev. If you've checked that, then you would ask, are there unnecessary updates being performed here? I know that's every React performance article and talk, but it's so important that I'm going to dig into it again here. And then you might ask, is the component tree changing? This is a bit of a subtler issue, but can absolutely destroy a page's performance. So unnecessary updates, you probably all heard this, but again, worth hammering home. This component, every time it's rendered, is going to update, even if it's a pure component. And the reason for that is that this list we're creating here, this React tree, it's a new object every time this renders. So pure component, it's only looking at reference equality for objects it receives. This isn't reference equal to the last list that was passed in, so the dropdown is going to update. So how do we avoid that? Well, the most straightforward way is to memoize that wrapper component, or to make it a pure component equivalently. And that's very nice. That means that as long as that wrapper component doesn't update or doesn't receive new props itself, this dropdown isn't going to update either. Nothing in that tree is going to update. But we are still paying the upfront cost of constructing this menu tree, even if the dropdown is closed. So we might be able to improve matters using a render prop. So here we have a function that actually constructs this React tree. And now we just pass that function into the dropdown component, and we have a render prop API here. And the idea is that the dropdown is only running this function when it's actually open, so this React tree is only constructed when it's actually needed. A slight variation on that is a component prop, and that's where instead of the component running a function, it instead uses this as a React component. And if you're looking carefully, you'll see this is exactly the same as the previous slide, only the naming conventions have changed, but the internals of dropdown are different here. Now, this convention of using a capitalized prop name for a component prop is pretty much unique to HubSpot. We've been using this convention internally for a while. I think it's very handy because it means we don't have to rename the component prop to something else before we create it. So I'm sort of hoping it'll catch on. Please take this with you. But that does induce a risk, the component prop approach, and that is that we may cause DOM thrashing. If a dev were to pass in an inline function here, that would occur for reasons that I'll explain. So let's look at another example where you have a, let's say you have an input that you want to show a tooltip around anytime that input is focused or hovered. And this component receives focused and hovered as props from some higher order component. So we create the input element here, and then we ask, okay, if this is focused or hovered, we'll wrap it in this tooltip. Otherwise, we'll just return the input. This is a terrible idea. The reason this is so terrible is that when this gets focused or hovered, React is going to say, oh, this tree is completely different now. I'm going to delete this input that I'd rendered in the DOM and replace it with a completely new input. So even though you're using the same element, because its parent is different, the React reconciler absolutely refuses to deal with it, and you end up with this very inefficient situation and also possible side effects, such as the input losing focus. So it's much nicer to use an API like this, where the tooltip takes an open prop, and this way you always have the same structure, and therefore nothing is going to change in the DOM. This is a really easy trap to fall into if you're using styled components. We started embracing styled components at HubSpot about a year ago, and it is so tempting for people to use styled components like this. Here we have a component that's receiving a color prop, and it just interpolates that color into a styled component, renders that styled button. Now the button has that color, but every time this function is called, it's a new component, which means that React is going to replace that button in the DOM. So it's incredibly inefficient and could create other weird artifacts. So you have to be careful to instead take advantage of styled components the proper way, which is to have this inline interpolated function where the props passed to the styled component are how it computes the values of its styles. Okay, so let's say you've looked at those common causes of inefficiency, and now you're ready to dig deeper. You want to find out, will it make a difference if I make some tweak to my component? And for that, you're going to have to use a benchmark. And you're probably familiar with the React 16 profiler, which is a great way to take a first step at looking at a component and see, like, oh, here's the thing that's really sluggish on this page. But once you've identified that thing, I find the React profiler, it's too noisy. Like, you're going to get a huge amount of variance because so much else is going on the page. So we want to minimize the noise to signal ratio. There's always some noise in a performance benchmark, but we want to isolate as much as we can. So if we're interested in the performance of a particular component, we really just want to render that component. And then we want to repeat over and over again so that we can wash out this variance and look at a meaningful average. So for that, we'll use something called Puppeteer, which is just a thin wrapper around headless Chrome. So here's a script I created. This is a simple test page where I import the component that I'm interested in benchmarking, and then I just render it, say, 1,000 times on the page. And then after I've done that, I set some attribute on the page. And this is going to be my signal to the Puppeteer to tell it, OK, I'm done with what I'm doing. You can collect your metrics now. And that's just rendered to the page. Simple as that. Oh, and make sure that you run this in production mode, because again, if you're running in development mode, you're going to get a very skewed idea of what's slow and what's fast. Okay, so let's look at the script I used to run Puppeteer. This is something, this is based on a script I wrote for HubSpot a few months ago that's proven enormously useful. So this is a node script. You bring in Puppeteer, and then I've accepted the URL as an argument and run an async function. I wait for Puppeteer to launch, open a new page, then navigate to this local URL, which is just the page that you just saw, and wait for that attribute to be in the DOM. And if you've used Selenium before, this API should look very familiar. It's just waiting for this query selector to be resolved. And then you tell it, await page.metrics, which means collect all the data you can, then finish up and show me that data. And let's see how that works. I've got this running live on my machine. And here I've enhanced that script a bit so it does multiple repetitions and will show the data in a neat little table. And you can see some of the kinds of data that Puppeteer can collect here, like you have the total script duration at the top. That's probably the thing you're most interested in when it comes to React components, because that's the amount of time spent in the React render process, more or less. And then there's the style recalculation duration. I'll talk a little bit about that later. Usually not significant, but sometimes very significant. And you can look at layout duration, which is especially important if you're doing something like the measurement logic that we saw before, because measurement is going to potentially induce extra layouts. You want to minimize that. And then it also reports total task duration and heap size. Heap size I'm very interested in because every time you create a React element, you're throwing another object on the heap, and that's a big source of the performance drain in rendering React components, and a big source of the reason that React performance is interesting. Unfortunately, there's a lot of variance in that number. The browser just randomly allocates more or less heap sometimes, so you have to get a lot of repetitions for that number to be meaningful. Okay, so I said I'd talk about recalc's duration. So I was running this benchmark. I had 1,000 elements in a row, and I saw that it was taking like 200 milliseconds to calculate the styles. And I tried, like, when I only had 100 things in a row, that number was negligible. If I made it 10,000 things in a row, that number was 3 seconds. So the amount of time it took to recalculate styles is going up exponentially with the number of elements in a row. And it turns out it was because of this one selector. And for those of you who don't immediately recognize what's so horrible about this. That middle part is the adjacent sibling selector, so it looks at all adjacent siblings. And that last part, of course, the asterisk matches everything. And CSS selectors are evaluated from right to left, which means that for every element on the page, this selector was making the browser look at all previous elements, all previous siblings to that element, and ask, okay, does it have this class? Does it have this class? So as a result, lists of elements in HubSpot were taking an exponential amount of time to calculate styles. And that is exactly the sort of thing that I don't think I would ever have discovered without Puppeteer. So wrapping up, some takeaways from this. I think shallow testing is actually pretty cool. I think, of course, React Testing Library also pretty cool. But there are some uses that you might find for shallow testing on its own. And perf bugs, I talked about some common bugs and common solutions for them. And then I talked about using Puppeteer to measure that. Now, I'd be remiss if I didn't plug my book again, available from practbug.com. It's actually not at all overlapping with this talk. It's much more about setting up an efficient workflow for yourself and really enjoying the process of test-driven development. And that's it for me. Thank you very much.
That was pretty cool. So we're going to have a quick Q&A. So if any of you have any questions, we're going to have a couple of volunteers with mics. So raise your hand if you have any questions for Trevor. Just a moment.
You mentioned Puppeteer. Are there any other tools you would like to use it, like a Cypress or something else?
So the question is, are there any other tools other than Puppeteer that you like to use for this sort of looking at a page and measuring? I think Puppeteer is perfect for this sort of looking at a page locally and just getting these page metrics out of it. Certainly, if you're interested in like network performance, you would look at a different tool. I don't really know what you mentioned Cypress, which I think is one of those more interested in like how things are on the network. So that, what's nice about this is you're taking the network component out of this. You're really just collecting the browser benchmarks itself.
Anyone else? Just a moment.
You mentioned the pyramid.
Sorry, so we need a mic for questions, otherwise everyone is not going to be able to hear us. Yeah.
You show the diagram pyramid, which got unit test, integration test. We didn't mention much about end-to-end test.
Yeah. So the question is why I didn't mention end-to-end test. We use Selenium at HubSpot pretty heavily. In my particular role, like I said, I build components, so I'm not really involved in that sort of testing because I don't write the applications that the components run in. So my area of expertise is more this, with looking at the components in isolation as much as possible. But Selenium is definitely very helpful on top of the sort of tests I've talked about.
We had one there somewhere. Yeah.
So does the HubSpot bundle that we have right now support Puppeteer out of box, and how to include it in the projects that we have from the company?
Go onto the HubSpot GitHub and get Render Benchmark app. It's its own isolated application. And just load the components you're interested in there.
Anyone else? There's one there. Okay.
Thank you. Cypress is a Selenium competitor, so you'd use it instead of Selenium or WebDriver O. So that's probably why he was mentioned. This is a little tools question. Everyone does this, it seems. Everyone seems to want to test blind. Do you not find Jest a bit awkward, not being able to see anything? Or is this something I'm missing?
That's a good question. So we actually do use visual regression testing in addition to the aforementioned unit tests. There are certainly a lot of things you can catch that way that you can't catch otherwise. A unit test thinks that your button is working perfectly fine when it actually has display none, so someone can't actually click it. Yeah, I mean, there are so many layers of testing, and it'd be great if we could bring them all together in some meaningful way, but as far as I know, you really need the separate layers, the unit tests.
Oh, no, I mean, I still mean at the UT-AT integration level, you just use Karma instead. It seems everyone uses Jest, and I mean, we use it in some of our projects, but it's quite odd. I don't get it, because we build visual components, and you don't see anything. Like, React Testing Library has a debug method that allows you to print out the DOM to the console. This is farcical. I mean, you write your tests, you debug them, and you can't see anything. And if you just use Karma, it sticks it there in the DOM. You have a debugger, it's stopped right there in front of you. You can see exactly what is actually being rendered in the real world with the styles and all. And I'm really baffled as to why people, even writing simple tests for like drop-downs, it becomes more difficult. You have to actually go into the component and try and figure out which events to trigger on which DOM elements to get the drop-down to open. But like with Karma, you see it, and you can actually like run that in the console, and you just stick an event on that, or just call this event. It's much easier. I kind of confuse as why people are.
Well, that sounds great. I haven't used Karma myself, but I'll certainly look into it. I think the big advantage of Jest is that it's enormously fast. You know, it doesn't involve a real browser. All your tests can run in parallel. We have thousands of components that we test in UI components, so being able to run all those tests in a few seconds is just fantastic.
Yeah, Karma does too. I don't get it. Karma, but like, it's not magic. Jest runs on Node, that's the V8 engine. You run your Karma tests on Chrome, that's the V8 engine. There's no magic. It's the exact same JavaScript engine.
I think we will need to do some research and do another topic next time at the next event on Karma. So
yeah, speak at the next meetup.
Definitely, if you like to have a talk on that topic, feel free. Anyone else? Let's go with this one first.
Yeah, I could have enabled my microphone, by the way, but okay. So I actually have an interesting question in terms of I find that unit tests become old super fast. So like you would write the tests, and then like in a week everything has changed. So you need to rewrite the whole thing again because it was so intrusive. It knew what was inside of your components. So is there like any technique in particular that you would recommend to like maybe like what not to test in the unit tests? You know, like not to make them become old so quickly.
Yeah, I mean, that's one of the huge advantages of shallow testing when it's done properly, that really nothing outside of the component you're testing can affect those tests, so they tend to be much more stable. The other thing about unit tests is that they're very cheap, generally speaking, so you can throw them out, replace them very quickly, as opposed to something like Selenium test. I think there's no silver bullet for some degree of tests getting stale. But I would say definitely when writing a test, think about how changes outside of the module you're testing could potentially impact that test.
I think we can take one more, and this gentleman over there is raising a hand for a long time. Maybe two more. One is... You need to shout then.
Yeah, so to go through it all, to go through the HubSpot pyramid, as it were, we have a ton of unit tests at the bottom, which are mostly shallow tests. We're sort of moving toward having more integration tests on top of that, but don't have many right now. And then we have visual regression testing in the UI components library, which is a custom script that we wrote that takes snapshots every evening of every component. Sadly, we can't do that every time something changes because it's just too slow. And then we have the Selenium tests, but those all live at the level of individual applications. There is one application that's we call it the kitchen sink app. That's like as many components as we can throw in there. That we're just trying to throw Selenium at it. and those tests run every hour. But it's been a mixed blessing for us because the Selenium is just prone to false positives, and so we get a lot of alerts that aren't very meaningful for us. Whereas the unit tests, which really are the basis of our testing, are very stable and not prone to that kind of random failure.
Awesome. And the very last one, go for it.
Okay, so you've mentioned both React Testing Library and Enzyme, and at a glance, there might be some overlap between them, especially since Enzyme also has the render function. And my question is, would you use both of them in a single project, Enzyme for shallow testing and React Testing Library for rendering, or this is like, you think, more like decision to make for a project?
I think you absolutely can use the two as complements to each other. For the kinds of use cases I talked about where testing the DOM isn't very meaningful, you can just bring in Enzyme for those cases. There's no reason you have to try to use the same library for everything.
Okay, thanks.
Thank you so much, everyone. So we have some ice cream back in the kitchen. We have more drinks. Be sure to load and come back here so that we have more space. And let's come back in some 15 minutes. See ya. Hello and welcome back.
It's on.
Okay, so I think we're all mostly back. I'll give you a small pro tip that I just discovered from Ms. Hub. So when you're grabbing beers out of the fridge, watch out because some of them are 0, which you realize only once you drink half of the bottle. So watch out for those that are 0. So next up is Roxana talking about relay and hooks. So welcome.
Hello. Can you hear me? Okay, fine. So, hi. My name is Roxana, and I work in Facebook. And I need my presentation on this screen, please. Hey. Weird. Okay. Yes. Okay. First things first. Okay, so my name is Roxana. You probably already figured that one out. So before we start addressing the topic of this talk, I would want to ask you one question. Have you ever worked with GraphQL before? And if you did, raise the hand. All right, cool. So not only me, this is really nice. So going forward with that, I started in Facebook 8 months ago. So since then, I've been working with GraphQL. And this is the full disclosure, only 8 months. But I want to start off this with talking about GraphQL, because a lot of things that Relay does is related to what kind of problems GraphQL introduce. So let's talk about what is GraphQL, for those who don't know, and hopefully in the end of this talk you would know GraphQL and Relay together, right? Very nice. So GraphQL is a declarative query language, right? Declarative query language that introduces the way to define your APIs with schemas. As you can see here, you define the query, and it would be 2 endpoints, get users, right? And the results are also defined pretty strictly. Then the idea behind GraphQL is that you would only query the things that you need to be querying. Let me go into this more specifically so that we will be all on the same page. So imagine you have an API, and that the API has 120 different, like it's a user profile, right? And it has like a bunch of fields in that. And you have, in your UI, you have about 20 different components that will be querying or needing the data from that API to be rendering something, like saying the user photo and username and so on and so forth. So in the REST world, at this point, what you would be doing is creating an endpoint. It will be serving you this 120 fields. Then you would be having some complicated data passing props through the React components down the stream, in the meantime losing half of the data, or for example forgetting to pass something, or pass too much. So it kind of leads to something that is called overfetching, or underfetching, depending on what you want. So imagine that like you thought about this, and you thought, okay, why wouldn't I provide some query parameters to the endpoint, right? Like I would pass in all the parameters that I want to be querying at once from this endpoint through the query parameters, right? Okay, so I congratulate you because you just invented GraphQL, right? Now, it's a bit more complicated than that, obviously, but this is the essence of it. In GraphQL, what happens is that server defines the maximum of what it can give, and clients on their own choose only the parts of what they want from those queries. Now, GraphQL in itself is just a definition
of, it's a language, basically, right? The definition of language. So the actual implementation that happens with GraphQL is kind of language agnostic. And GraphQL server can be written in Go, can be written in Java, can be written in any other major language. So normally with GraphQL servers, what user does to start using GraphQL server, he implements, or she implements the schema that defines the APIs and the exact things that those API endpoints would be returning, and the resolvers. And the resolver is interesting. Resolver is the thing, the function, that exactly fulfills your data from all the data sources that you would be having. And what is interesting in GraphQL is that resolver, one of the parameters of any resolver, that would be, it is query in itself, right? All those query parameters that you want to fulfill. It prevents you from not, like GraphQL basically allows you to specify your data requirements so that you can use them while fetching those from your data sources as well, which prevents you, like you can avoid, for example, an additional join or additional go into some kind of API, right? And that is very nice. You can narrow the search, let's say, and it gets faster by that, right? So if anything to remember about GraphQL servers, I want you to remember those things. So the first thing that any GraphQL server will be working with is the schema. The schema over which you can perform queries, and you will get responses. And responses always contain only those things that the queries specified as the data requirement. And queries do not need to contain all the fields that the schema provides, right? And resolvers would transform an actual instance of a query, right? Not the, like, all the schema, the instance of a query into your data. Now, going back into Relay, I want to go back even a bit and brought you a bit of understanding before we go into the Relay. So imagine that we've started using our API, our GraphQL API. And we have those 20 components, right? And those 20 components, one would request the name. One would request name and the photo. Another would request name, photo, and something else, right? It doesn't feel like we're not overfetching, right? There is some additional step. It feels like there is some additional step that we want to be making to avoid that overfetching, right? So we want potentially to maybe merge all the data requirements into something that would be fetched only once and then somehow magically spread it to the components, right? Okay, so at this point you've invented Relay. Yeah. So the major selling point of Relay is the optimizations that it's doing over the queries that are performed in the application and its composability. The people would always laugh that like it's not a word. No, it is a word, but like what I mean by this is that queries and components, they have the same hierarchy. With Relay, if the component uses something, a part of a data, that would be a query that would be representing that data, and it will be collocated with that component. And in that way, it creates the same hierarchy, the same ideas based on which the React is working, right? And that what enables React to be composable, like to promote composability, right? Okay, so I want you to also think about Relay as the declarative data fetching framework. It means that you always kind of know what you're requesting, like what is the domain of what you're requesting. It's pretty interesting. Now, I want to represent two of those points over the demo. So I'll stop the slides. And I wrote a bit of code just to put things into perspective. Okay. So what we're seeing here is a simple React component written in Relay. This component queries a thing, and it's been user query, kind of. It uses the endpoint get users that we've seen before from this schema. Here goes, right? And the data is being fulfilled with the resolver that we've had before. And so here, we're querying the list of users, right? And the weirdness is already started, so let's talk about this. This is a directive. Relay allows you to fight off the complexities and weirdness of GraphQL in itself by providing you simple directives that would just handle this stuff for you. So with GraphQL, lists are kind of weird because lists are not very effective in terms of fetching, right? And lists are not effective for rendering because they normally, by default, do not have IDs, right? So when you want to append to the list, a lot of frameworks, like if you don't have IDs, they'll be like, okay, I need to render everything. I don't know what you've changed, right? Now, really kind of allows you to avoid this stuff. Now, and here as well, you can see that we've fetched only one field, and that is ID. What is interesting is the point that I made on the slide, and it's a collocation of data and rendering, right? In here, I want to only query the ID because the user's component will render things just like that. It doesn't need more than the ID, right? We are using ID for the key in the list, and that is it. It is interesting because it also, it's not obvious from here, but it is interesting that it doesn't also allow this component to access anything of the of data that is stored in the user. It does query it because this, what we're looking at, is a fragment. So it means that we will get the whole list of users, but this component will not be able to access any of it. It will only see the ID. And in that way, it means that we masked our data from the component. And it means this component cannot do anything to our data, which is very important for big projects, I think. Don't you agree, right? So now the query will be rendered by the fragment. So this is the requirement for the fragment, which gets everything. Now you can see one fun thing. We queried ID here as well. Here and here. Is it overfetching? Who knows, right? Let me tell you. Okay, going back into that cool presenter mode. So, three things that are in together create the relay as we know it. Relay compiler, relay runtime, and relay components for React, obviously. So relay compiler is that thing that solves the problem that we've seen just now. The fragment in itself and the list query, right, queries the same part of the object, which is ID. We don't want to query it twice. We want to query it all together because we know that every time that we will be querying the get users, also the fragment will be queried, right? So what relay compiler does, it kind of transforms things. It flattens the data requirements, right? So it avoids, it specifically creates, scans everything in your project and finds those situations where you can flatten your data requirement and flattens them, which is nice, right? Now, GraphQL is complicated, and Relay compiler makes it easier by giving you insight in what your actual queries will be statically. So it means that it will scan all your project and find all your queries that you're making and provide you with generated Relay queries beforehand, before you even started running. It is important in GraphQL world because, as you have seen, the queries are kind of dynamic, right? They're kind of like not the part of the schema. When you've defined the schema, you still have to think about your queries a bit more, right? So what Relay compiler also enables you to do is to prefetch certain things. Because, for example, like you have a single page application and you want to preload something, like so it would be faster, like not to do like 10 queries at once. You want this like initial state to be there, right? Okay, so this is what it does. It allows you to create all the queries, to like extract all the queries that are required for your first page and serve it in one bunch without actually making like 10 queries in the runtime. Cool. Now, Relay compiler allows you for validation for your data requirements in the compile time. So you will never, ever use a field that is not there, that is not fetched from the, like, well, obviously you can return null from the backend. That is not a problem, right? Well, it is a problem, kind of. Who cares? We kind of do not allow for that. Like, if that is a null, it's a legit null. It's a null from the server. It's not something that you forgot to query, right? So it also like merges the repeated data requirements, and it provides you something that is very important for handling union types in GraphQL. Have anyone been using union types? GraphQL? No? Cool. Yes. All right, we have one. Two. Cool, Paul. So now, what is cool about this is that it allows you to return slightly different things in one, like the union types allow you to return slightly different things from one GraphQL endpoint. And it's cool because the type name is cool because it allows you to match upon those. And your UI will know what kind of type you've been served, right? And in terms of typing, Relay compiler will also provide you flow types for all your queries and query results, right? So it's not only flow types, by the way, it's also TypeScript, but like with a bit more magic going on. So another important thing is that Relay also supports conditionals, which means like you can slightly tweak your query depending on what is the state of the component that is querying. Now, compiler is cool. The Relay runtime is way cooler, so strap on because this is gonna be intense. So now the major two modules that runtime contains is store and network. One is essentially a cache that is like really, really complicated and cool cache. And network would be handling things like security, how you fetch, how you manage subscriptions, and so on and so forth, like basically how you bring in the data in your application. And in one Relay application, you may have more than one environment. So you might go to a specific API in a specific way, in a specific way, and in the completely different way, and so on and so forth. And all of that will have separate caches, separate networks. It's all isolated. And it's interesting that it kind of separates the concern of like how you fetch things away from you. So you only think about your data, your queries. Right. So what Relay runtime does is optimizes your cache. I think like we've all been writing applications that would have the cache in them, right? But we never been thinking like, okay, I definitely need it normalized. Yeah, and working on that proactively for a very long time, did we? Okay, I know this one we didn't do it at all, ever. So cache is being growing, and what do you do with that? Well, you need some garbage collection to happen. Did you ever implement the garbage collection on your UI caches? No, the user will overload, right? Now, Relay also provides you means to write two neat things. Pagination and handle things like subscriptions and live queries. I'll show you the example in the demo a bit later then. So I want to stop and talk about store a bit more, because this is something that people perceive as very, very complicated about Relay. And I do understand why. And let me illustrate you with the example. So here you can see a fragment, right? And it's been a fragment on a user. That fragment being fulfilled, this is the response. So at the moment when we get this response, right, this is what Relay does to that. Okay, so we got the name. Here is the name, Joe, right? We got the address, and at this point, this is what is called normalization. Normalization is basically assigning an ID to anything and flatten it down so that it can be later accessed super fast by ID, right? So you never manage things in the list. No, like you have lists, and this is list of IDs, and that's it. And everything else is mergeable in. It's like you have things that would be accessible to you by ID, and you always know that this thing and this thing is the same when the response comes from the server, and you merge into a specific thing. So 3 things that store provides you. First, there's normalization magic that goes on, right? Then when this object comes into the store, it's going to be published into the store. It means essentially being merged. And then, the fun fact, the third thing happens. What does Notify do? Well, Notify is an interesting bunch. It will take all those merges that happened, and it will let the UI know that those parts that UI been showing out of the store being updated. And at this point, a very effective render will happen. Okay. Anyone used Redux? What? Okay. No, hands up. Hands up. Okay. Well, that's better. That's better. All right. At this point, you might ask me, like, well, those both kind of work with data, don't they? Well, yes, but Redux is more about workflows, and it's more about, well, it is about data, but is it about GraphQL? No, I don't think so, right? It's a bit different. There's a bit different focus that we're talking about. The Redux is about, well, I will bring this data and I will put it in with my own hands, and I'll manage this UI cache in a very effective way, I promise you. And maybe at some point I will implement that garbage collection, right? I don't know, I never did. Now, with the Relay, it's more about data. It's more about data and GraphQL being available for big projects. It's about like, well, I don't care. I don't want to care about like how the garbage collection is done. It's done, okay? Now, I want to be making sure that I'm writing the components in the best way possible. And maybe testing them, as a previous talk I was talking about, right? Because my hands are free from the fetching problems. I want to briefly touch on this. Unfortunately, I don't have enough time for this, but the Relay and hooks are working together nicely. And you know why? Because kind of both are built for React. Those are built with React in mind. Those are built with hierarchies and composability in mind that are built like on the same basic premise of how an application should be built, right? React way, let's call it like this. So right now there is a module actually that handles the basic primitives of Relay with hooks. And that works nicely. But again, reason being is that React is the basis for both those technologies. They've been built specifically for working with React, which is cool. Now, I find personally, from my personal experience, that Relay, for any side effects that you need to introduce as a result of your component being rendered, or the moment when you render something you want to create a subscription or whatever, use effect works perfectly well for most cases, and you wouldn't need anything additional. Just use that. Though there are cases like client-specific fields, for example, or injected client fields. That would be the situations which you would say, oh, yeah, I miss Flux a lot. I want more of control for that stuff. Well, there is a store API for this. Store API is the direct access into what's stored, what's in the store of Relay right now, right? It will allow you to create certain things, certain reactions to certain parts of data being updated, for example. You can, I don't know, parse out things out of the huge texts that would be passed down to you and Memoize the results and made it available anywhere where the fragment would be requesting it. It's fine. It's doable, though slightly complicated. Well, not slightly. A bit more complicated than you wish it to be, though my hope is that in the future we'll get it a bit better. Now, what you can do next is go on, learn about GraphQL. I would strongly suggest the first link. It starts off with very simple examples, and you go into awesome step-by-step tutorials, and I would definitely, if you really want to know anything about GraphQL, I would definitely start from that. Then I would also suggest you, if you want specifically to work with Relay or thinking about something like this, go read the docs. They're written very simply. It's really easy to start, and there is also a lot of people in the community that are working constantly on keeping those things. It's all open source, obviously, so looking forward to see what you're going to write in Relay. It's very interesting for me to, if anyone after that would decide to do that, please reach out. Okay, so the summary. If anything to know about this talk, right? Well, 3 things. What is Relay? Well, it's a very, very optimized GraphQL client JavaScript React library. It provides you with cache optimizations and cache garbage collection. By the way, you don't need to understand any of those optimizations to use them. It's all for free. And then the network definition, the way you connect to your backends, if that's not just one server, but a bunch of fleet or whatever. The network implementation of the Relay will allow you to neatly separate the implementation of the connection and reconnection and everything completely separately from your application. So it's very nice isolation of that thing. And with this, thank you very much.
Thank you very much. This was amazing. So we're going to take a few questions for Oksana as well. Before that, I'll just say something super important, because otherwise I might forget. So we will, as always, send you feedback questionnaire to fill in. So please send us feedback. We read every single feedback. We action on it, and we take it really seriously. An example, this time we've moved back, you probably noticed, we moved back the meetup time, because last time we kind of experimented with something a little bit earlier in the day. So a lot of people said that it's too early for them to get here. So please leave us feedback. If you have ideas for next topics, please leave those ideas in the feedback comment as well. If you want to speak at one of the next events, please reach out to meetup.com as well. So, questions?
You said that you compile against a schema, but if the backend doesn't match that schema,
what happens?
Yeah.
Well, error happens. So what happens is that it's not only schema. So what Relay will do, it will go through all of the components and will find all of the definitions for all queries that every single part of your UI is making. And it will compile this intermediate representation for all your queries. It will transform them, and then the results will be validated against your schema.
So it makes sure it's compatible
yes,
with
and
what
it
you
makes sure that if you're requesting for that name field, it is in the schema and it's been fulfilled. Yeah.
I know it's probably a more technical question. Do you know how much work it would be to switch Relay from GraphQL to another metadata-driven language? Do you think that's a big issue, or?
Well, what I find interesting with Relay and GraphQL in general is that it's doable in steps. It's a very iterative process. So you can start off today and make a little like part of your application GraphQL and go iterate a bit more and add on that huge endpoint that will be serving 120 lines, you know. And at some point you'll get there. Yeah.
I was actually thinking more to have OData as a backend rather than GraphQL.
Sure. Whatever you want. We can talk about this after the presentation, so no problem.
Hi. My experience with GraphQL has mostly been through Apollo. How does Relay handle mocking in relation to testing and stuff like that? Just to bring back the previous talk as well.
Well, it's pretty much the same way as Apollo does that. So I guess nothing to add on this. It's more or less boils down to the point of like, what are you mocking? So what do you want to be like? What are you testing? What is the like if you want to provide the data, the store API probably is going to be the best point. If you want to test the rendering, well, you can do this in isolation as it was shown before. Well, I don't have the particular like Relay way of doing this. It's all pretty much the same thing. Yeah. Sorry, maybe I didn't. I didn't work that much with Apollo. I only researched it as the part of this talk. So, you know, I looked into it, but not too much.
Hello. I will start by saying amazing talk. I really enjoyed it. I think you should totally.
He's
also
my colleague, by the way. So
I think you should actually do it inside Facebook because I finally know what I've been coding for the past year.
Yeah.
So it's nice. Maybe just like open question because we talk about like Relay, React, GraphQL as a package. What is your like personal opinion? It's like open-ended question to everyone. Would you consider using only part of this, or the actual benefits you're getting is only when you use the whole stack, the whole family of the things?
Well, I find that it's gonna be super hard to use GraphQL, to use Relay with anything else than React. So I would say that React is kind of inseparable, so to speak. Obviously, as is GraphQL. So I would say like using those together is imperative. Though it doesn't mean that if in the application you would be using something like Redux for something that is like flow-oriented, or you have like a clicky wizard, something like that, you want to keep something in memory, you know, just to handle this kind of use cases. Well, it's nice to have Redux. I'm not like totally against it or anything. Like I'm totally for Redux, to be honest with you. I would say that Relay, with all its bunch of implementations and things, is a very nice complementary to projects that would be working with showing data, with refetching data, which keeping data up to date, right? Like something like dashboard, for example, or something like, well, we've queried this, but it can get updated at any time, right? This kind of applications, and then Redux and this kind of like Flux-oriented solutions that could be complementary to Relay. They could go and handle the parts of the application that are related to user interactions and like user filling like huge forms or something like this, and you need to store intermediate steps and, you know, this kind of things. I hope I answered your question.
There are many projects, I guess, that right now are using React and Redux for quite a long time. And some of its selling points was a single source of truth or separation of concerns. And now with Relay, I feel that this is introducing second source of truth with a second store if you have an existing project that has been spinning around for a few years. And now we are saying, well, maybe it's better actually to get the data management in the components because, like, if you display the user in some component, fetch the data for the user in this component. But if we have existing project that was following the other philosophy basically, and has some, I don't know, Redux Saga or Redux Observable or whatever for fetching data, is there some API in Relay that would allow you to integrate with existing solutions, or how would you tackle that, basically?
That's a very, very interesting question. Now, what I would suggest, right, is to understand what is the, like, it's just a technique. It's not a framework or anything. But what I would do is understand what is the data requirement in the component itself, right? So list down what is the parts of the data that you're using in that component, and then define a fragment based on that. After this, you can spin off and define more fragments all over the place where you know what your data requirements are. And at this point, Relay will provide you with more or less data model, out of which you can figure out what would be your endpoints and what kind of data it needs to serve to fulfill all those things. So it all boils down with Relay to the concept of data in the end, like what it needs to be showing. And it takes this like complexity of fetching and like passing through the whole, you know, like the props hell going on. Like it takes that away. You don't need to do this anymore because fragment kind of defines your data requirements. Yeah, again, it can be done iteratively in a way. Yeah.
Do we have anyone else? There's one there.
Yeah.
So you say about the props hell, like the problem of passing props down, and the fragment would solve that. When you're giving an example of spreading the fragment, it means that you're merging the properties in the query, wasn't it?
Can you repeat that?
You were fetching ID and you were spreading the two other fragments there. You're merging the props that you are getting in there, which means also that you need to understand what components you're using down the tree to use the correct fragment. That creates a bit of coupling between them, no?
It's a very small amount of coupling, so to speak, in comparison, I mean, because you don't need to go, like, to boil down to the specifics, like a name or whatever, because the final extraction happens on the level of the component that actually uses the data, right? So it's kind of like, yeah, I agree that in a way it does do that, but again, it's way less complicated in the end. Yeah. No.
Maybe one more. Last call. I don't see anyone. If you have a question, raise your hand really high. Okay, so that's it. Thank you all for coming, and I'll see you on the next meetup.